very good morning to all my dear students. It's raining outside in school and I think it's a perfect time to start our revision for PA2 assessment, PA2 examination. Children, before I begin, I would like to just share a very important thing with all of you that I've been getting many phone calls from your parents complaining that you are not following the video lessons properly. Just before the examinations, if you start searching for all the video lessons, it will be very difficult for you to understand the whole topic well, children. So it's my sincere request to follow all the video lessons and be updated. Okay? Let's begin our revision. So we have chapter 12 friction and chapter 5 coal and petroleum for our PA2 syllabus. Okay, for our PA2 exam, we have two chapters in physics and chemistry, that is friction and coal and petroleum. So friction we have completed maybe I think in the last month, and then we completed our coal and petroleum chapter. Now let us see one by one what are the key points that are there that have to be revised once again so that you score good marks in your exam. First of all, friction. It's such an easy lesson. If you have understood force and pressure well, friction is not a big deal. It's such an easy lesson. So what is friction, children? It is a kind of force. What kind of force, children? Can you tell me what type of force is it? Whether a contact force or a non-contact force? Yes, it is a contact force which opposes the relative motions between the surfaces which are in contact with each other. So it is an opposing force. To put simply, it is nothing but an opposing force which restricts, or which does not allow free motion of an object. Okay. So it opposes the relative motion of the surfaces that are in contact with each other. So what are the properties? As I already told you, properties, nothing but it's a kind of contact force. It's also nothing but force. It's also measured in newtons. And this force is nothing but it acts in opposite direction always. So those are the properties of friction. We know that there are three types of friction: static friction, sliding friction and rolling friction. Static friction is that friction which comes into play when an object is at rest. So if it is not moving, if it is on the ground, say a table or a chair, then when you try to move, then it becomes a little difficult for us because it offers more friction, because at that time when an object is at rest, the interlockings will be more. So when the interlockings are more, then it offers more friction. So that friction is nothing but called as static friction. Once it starts, so this friction is nothing but just before movement we experience that kind of friction, static friction. Now, sliding friction is nothing but that friction when an object slides over another object. So, nothing but it is sliding. Okay, when an object moves past another surface or another object. Okay, when it slides over another object, sliding friction comes into play. And rolling friction is that friction when an object rolls over another body. So we have three types of friction, and out of all these three, which friction is least? Rolling friction is least, because easily you can move very heavy furniture or very heavy objects also from one place to another if they have wheels in it. That's the reason very heavy furniture and all, they are provided with wheels, because wheels roll, and because of that when it is rolling, the interlocking also will be very, very less, and that's the reason why we consider rolling friction as the least type of the friction that offers the least amount of friction. So it's such a short and easy chapter, children. We have got very few important things that can be asked in the examinations, children. As I told you, what is friction? It's just for your understanding. And types also. One question can come from these types also. As you can see that the one which offers more amount of friction is static and the least amount of friction is rolling. And then coming to the advantages and disadvantages of friction. we know that friction, it's very, very important, children. Many times questions can come from this topic also, like advantages and disadvantages. Why is friction considered as a friend and a foe? Foe means enemy. So that means one which is advantageous and the other side, like every coin has two sides, we say, no? So in the similar manner, friction also has advantages and has also got some disadvantages also. So we have already discussed advantages. What is advantage? If there was no friction, then the buildings would not stand erect. You can't hit a nail. It has to hold. The nail has to be held inside the wall such that you can hang something on it. And in order to write something on the board with the chalk, you need to have that friction, because of which because of the friction only the chalk makes an impression on the board, right? In the pencil, the graphite nib, isn't it? That also the paper should offer some friction such that the pencil writes on the piece of paper, right? And in the similar manner, if the floor is very slippery, you can't walk properly, you can't run, you can't even walk if there is no friction. So nothing, the moving object will not stop. So the brakes are applied. Brakes is nothing but it is offering certain friction to the moving wheels such that they are stopped, right? So even the roads are not so smooth. They are made coarse or rough, a little rough, because it has to give some friction to the vehicles that are moving on it. Even the tires, the treading, what you call tread, the treads of the tire also offers a lot of friction. They are not very smooth in order to give a good grip on the road, isn't it? So all these are nothing but the advantages of friction. We can't imagine our lives without friction at all. But in some cases, it is little disadvantages also, because more amount of friction leads to wear and tear of the objects. You can see that the tires of the vehicles, they become little smoother after a course of time. After a period of time, you can see that they become little very smoother, and because of which the bikes or the vehicles could skid, isn't it? So those are the disadvantages. And if there is more friction, it produces heat, and because of this heat production, many machine parts get damaged. And that is also one more very good point over here in disadvantages. It produces a lot of heat which could damage the machinery part. One is wear and tear of the things. So when any two surfaces are continuously rubbing against each other, then what happens? You can see that both the surfaces get damaged, both the surfaces get worn out. That we don't want. Again, you need to replace those parts. So that is disadvantages of friction. So very important point, subject point of view as well as examination point of view, children, here, because the friction causes wear and tear of the objects. Okay. And also it has got some advantages also. Why is friction considered as both friend and a foe? If it is there, then you have to write down both these advantages and disadvantages. How to increase or decrease friction? Now this is also very important concept in this chapter. Why in some places, in some categories or areas, we need to increase the friction, and in some cases we need to decrease the friction. So in some places you need to increase the friction, and in some places you need to decrease the friction. So how are you going to do that? How are you going to increase the friction? And first of all, you have to know where you have to increase the friction and where you have to decrease the friction. As I already told you that, the machine parts, in order to move very freely, you need to add some lubricants to it, so that the surfaces which are in continuous rubbing with each other, if they are continuously rubbing each other, in such cases you need to decrease the friction so that the machine parts are not damaged. So in order to decrease the friction, what are you going to do? And in some places you have to increase the friction. As I told you that, the vehicle wheels or the tires, if they want to have a good grip on the ground, you have to actually increase the friction there. So how are you going to increase the friction there? Simple carom boards. We want our striker to go smoothly, the coins and all on the carom board, the caroms, in order to play smoothly, you need to sprinkle some powder over there. So what are you doing there? Are you decreasing the friction or increasing the friction? You are decreasing the friction there. So decreasing can be done by using some compounds or some things which are called as lubricants. Lubricants are those substances which decrease the friction. How are they going to decrease the friction, children? Already I told you what is the cause of friction. The interlockings between the jagged ends, nothing but uneven surfaces, rough surfaces, interlockings will be there. So when you add these lubricants, what is happening? When you add these lubricants, you see that the jagged or what you call the uneven surfaces, they become little even, and that's the reason why the surfaces become smoother and offer lesser friction. So lubricants are those which reduce the friction. Some lubricants can be in powdered form like that of the talcum powder also, and some can be even in liquid form, oil, right? And some can be in semi-solid form like the grease. So all these reduce the friction. When it comes to increasing friction, what we need to do is we have to make the surfaces little rough. That's the only thing which we do. So how to increase the friction? Like one example is nothing but when the weightlifter lifts the heavy weights, they apply some coarse powder on their hands so that their hands are not sweaty, because once if they are sweaty and oily, they can't lift that properly. So they just apply some coarse powder such that now they have a better grip and they can lift the weights well. In the similar manner, we have treading. We call that as treading, right? What is treading? So treads are provided on the tires. You can see some patterns will be there on the tires like this, which give a better grip. Even the skiing people, nothing but they on ice or snow. On ice basically they just do skiing, we call that sport as skiing. So that they also wear a special kind of shoes. Not only skiing, even the football players also, they wear spiked shoes. The shoes have spike. Okay. The shoes have spikes here so that they have a better grip on the ground. So all these, what are we doing? We are just improving or increasing the grip over between two surfaces, and that is nothing but increasing friction. So all these are the main points that you have to remember, children. Apart from this, please go through the textbook and classwork. Some questions are ready-made, given in your notes, like already if they are given in your notes, but please try to write on your own. Simply don't type off in the Google and get the answers and write off during the examinations, children. We could see that some students are simply maybe by hearting or what, we don't know, but we could see that they are not using their own sentences in order to explain. Most of you are doing this mistake. Please don't mug up the answers, don't by heart them like that. Understand the concept and write on your own, children. Coming to the next chapter, coal and petroleum. It's another interesting chapter that we have learned so far, and if you remember, we started our lesson with the definitions of few things, like first of all fossil fuels. So what are fossil fuels? First of all, what is a fuel? Which burns in the air and produces energy and heat in the form of heat. So that substance which burns and produces heat is nothing but energy in the form of heat, is nothing but called as fuel. So what are fossil fuels? Those fuels which come from the remains, the dead remains of living things, like it can be from the vegetation or from the marine organisms, from the organisms, or both. So such fuels which are derived from the living organisms, they are called as fossil fuels. Okay. Now in that we have exhaustible and non-exhaustible, inexhaustible, exhaustive or exhaustible or inexhaustible natural resources, which now according to this, what is the definition of exhaustible natural resource? Those resources which are limited in nature and which can run out of supply because of some main reasons. Okay, because it takes millions of years for their formation, and if you just make it run out of supply, then if you just exhaust it, what you call, if you use it off, then it will take millions of years again to form. So they will not be available for us. Those fuels which are limited in nature, or which take very long time for formation, and they run out of, if they run out of supply, if they become unavailable, again it is very, very difficult to get them back. Such are called as exhaustible natural resources. Inexhaustible is quite the opposite. That means they are present in an unlimited amount in nature, and you can use it in how much ever amount you wish, and they are easily available also in nature, and they don't take much time for their formation. So you have to just know the basic differences. Exhaustible means which can be exhausted, which can be over, okay, which can be used up completely. Inexhaustible, which cannot be used up completely. There will be a constant or continuous supply of such things, like the sunlight or the water or the air. We get that, isn't it? In an unlimited manner. So renewable and non-renewable, as I told you, renew, that means they can be formed again. So both are almost the similar kind of definition you can give for both. Renewable means again they can be formed in no time. Non-renewable means they cannot be formed again, or it takes millions of years, so it will be definitely unavailable for us. So such fuels are called as non-renewable sources of energy. Sources, okay. Now fossil fuels come under which category, children? Non-renewable sources only, because it took thousands of millions of years for their formation, and because of which, if we completely use up all these fossil fuels, we'll be left with no more fuels in the future. So we have to use it very judiciously. Fuel efficiency is measured, as I told you. If you remember, I explained about an ideal fuel. What are the characteristics of an ideal fuel? It's not part of this lesson, but in order to understand the fuels well, I have taken one class. I had taken, if you remember, what are the characteristics of ideal fuel, children? Characteristics of ideal fuel means it has to have it has to liberate a lot of energy, more amount of energy, and it should be easily available. It should be easily transported. It should be eco-friendly. All that, isn't it? So how are you going to measure fuel efficiency? How to know which fuel is better than the other? There is one small formula. What is that? Mainly fuel is to derive energy from it, right? So fuel efficiency mainly focuses on the amount of energy that is released when 1 kilogram of substance is used, fuel is used. So amount of heat energy produced divided by the 1 kilogram of the mass of, divided by mass of what you call the fuel, okay. So amount of heat liberated by mass of the fuel, that which will give you fuel efficiency. So we have seen the formation of coal and formation of petroleum separately. We have seen the different types of coals, and how to get different substances out of coal also we have seen one by one. Like formation of coal, you know that it is mainly derived from the dead remains of vegetative matter. That is when forests, when they got buried deep into the earth's crust, deep inside the ground, because of some natural calamities like earthquakes or avalanches or whatever natural calamities, floods and all that. Because of that, what happened? Many forests got buried deep into the earth, and because of the pressure and temperature, high temperature and anoxic, that means lack of oxygen, that all led to the transformation of these vegetative matter into dark colored substance, which is nothing but coal. So we have seen the different types of coals also, depending upon the time of their buried, when the time when they got of their burial under the ground. So if it is a fresh type of coal, it is called as peat. Peat is a low quality coal because it is not completely transformed into carbon, nothing but coal, right? Carbonization, this transformation is called as carbonization, and you can see that it's just in the beginning of that process. It is just in the first stages of the process. So it is nothing but a low quality coal, okay? The fresh coal, what we say. So that is peat. And then after that, if you see, that it is lignite, so it is a little better quality when compared to peat. Then we have bitumen and we have anthracite, right? You remember, children? Anthracite is the best quality coal because it contains the highest amount of percentage of carbon in it. So you can see that the dead vegetative matter has slowly got transformed into nothing but carbon, and that is why it is called as carbonization. Correct, children? Now that coal, it has got, you can directly use the coal. Also, you can get few more components from the coal by destructive distillation of coal. So this is very, very important over here. Destructive distillation of coal, children. So what is it? Heating the coal in the absence of air. It will lead to three different byproducts. We get three different byproducts over here. What are they, children? We get coke, which is nothing but a solid byproduct. Coal tar, it is a liquid byproduct. And we get coal gas, which is a gaseous byproduct. Solid, liquid and gaseous. Solid coke, which is nothing but 99% pure carbon. And we get coal tar, liquid, and coal gas, which is nothing but a gas. We have like separate uses for all these three. Please go through the textbook. There is a table given very nicely. Go through the different uses, and examination point of view also it is very, very important. Then we come to the formation of petroleum. Now coming to the formation of petroleum, we know that it is derived from the marine sea organisms. Sometimes a mixture of marine sea plants as well as to little extent plants as well, and along with that the marine organisms mostly. So when they died, again the same process because of during that course of time, hundreds and millions of years, what happens? Because they get buried under the layers of sediments, and because of the natural calamities under the oceans also, under the seas also, you get earthquakes, and even because of the volcanic eruptions or maybe storms and all that. Because of all that, they get buried deeper and deeper into the layers of the earth's crust, and then because of that, because of the absence of oxygen, because of very high temperature and pressure, they get turned into a liquid-like substance actually, and there is also natural gas that is produced along with this. So they become into very dark colored viscous liquid, and after its formation, now what happens is slowly, because oil-like substance is formed, no? So oil has got lesser density when compared to water. So now these oil and natural gas layers, they get trapped between two impervious rocks. As I told you, impervious rocks are those rocks which do not allow passage of any substances through them. So they get trapped between two impervious rocks, and the reservoir rock, which is porous in nature, what is a reservoir rock like? It is nothing but, it is like a permeable, it has very small pores in which this oil, through which the oil can actually pass through, and a layer of oil and natural gas is formed above the water surface at certain areas. And at these places, if you drill an oil well, you can extract the petroleum, the crude oil, which is otherwise called as the crude oil, and the natural gas. So I have shown you one video where it is like this crude oil is actually drilled out of the well, and it is transported to the industrial plant. And now what happens to that? What is done with that crude oil? We can't use that crude oil as it is, because it is such viscous and if you burn such oil, it's very smoky. Okay, so it's like, instead of using the crude oil, you can actually separate many hundreds of components that are present in that crude oil, and then each one has got its own unique use, and you can use it in different ways. So for that purpose, what is done? The crude oil is subjected to, what is that type of separation, children, called? It is called as fractional distillation, right? Fractional distillation helps want to separate all the different components which are present in the crude oil in a stepwise manner, in a stage-wise or layer-wise manner. Nothing but fractional distillation column is a very long column in which you can see all the different components get separated at different levels, children. Can you tell me the principle behind this kind of separation? It is nothing but the boiling points, children. Depending upon their boiling points, they get separated. All the different components get separated such that the heavier components just stay at the bottom of the column, and the lighter ones, like the gas or the liquids, they which have got very low boiling points, they get separated from the top. So this is what happens. The substances with high boiling points, they separate at the bottom of the fractional column, and which have got very low boiling points, they still be in the form of gas and they are separated from the top. And again, those can be subjected to further distillation also depending upon the product that is formed. That is called as fractional distillation of petroleum. Right, children? So coming to the uses, as I already told you, every single component has got its own kind of use. So please follow, those two tables are very important. Sure, there will be some 2 to 3 questions coming from those two tables. One is different components of coal and different components of petroleum and their uses, children. Coming to the uses of fossil fuels, as you know that they are exhaustible natural resources, nothing but non-renewable sources of energy. Their use has to be limited, not only for the fact that they are exhaustible, also because of the fact that they are non-eco-friendly. You can see that they are not so eco-friendly. That means they release very toxic gases into the atmosphere, which leads to serious complications and consequences like the acid rains or most of the components actually which get separated, they also are non-eco-friendly, and they release very toxic gases, like they cause acid rains or even global warming also. So because of that, cleaner fuels are chosen. Cleaner fuels for vehicles is CNG, nothing but what is that? CNG, compressed natural gas, is the best choice for the vehicles because it is such an eco-friendly fuel for vehicles. Okay, so apart from CNG, you can see the other like petrol or the diesel, all these release toxic gases into the atmosphere, right? Kerosene, all these are not so eco-friendly. So that is why we have to limit the use of such fuels, children. So with this, we come to the end of our coal and petroleum chapter revision. So once again, I'm requesting you all to write in a very legible handwriting. Also, I will be just sending the blueprint also, like what the model paper, the blueprint for the PA2 assessment for physics and chemistry I will be sending. And please go through it and write in a very legible handwriting, children, and don't forget to mention your name on it. Okay? You mention your name on every page that you write, because so many papers we get at a time and it leads to little confusion. Okay, children? Thank you. Prepare well. Thank you.